Road to Olympiad.
Welcome to RTO. Consider the following problem. Consider the sequence 1, 1, 2, 1, 1, 2, 3, 1, 1, 2, 1, 1, 2, 3, 4, and so on. The sequence is obtained from the first term 1 by repeatedly carrying out step 1 and then step 2. Step 1. Copy the current sequence. Step 2. Write the integer after the current last term as the next term of the sequence. Find the sum of the first 2025 terms in the sequence. This is a sequence which is constructed from the previous sequence, so observation is very important so that we can find the invariant point for the sequence so that we could identify how the sequence will go on when the number of terms is getting bigger, and thus help us in finding the sum. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that by the way of constructions, we have A1 is equal to 1, A3 is equal to 2, A7 is equal to 3, A15 is equal to 4, and so on, where An is the n terms in the sequence. From the patterns, we can see that the first time the integer n will appear in the sequence is at the 2 to the power of n minus 1 term. So, if we have m is equal to 2 to the power of n minus 1 plus k, where k is between 1 and 2 to the power of n minus 1 inclusive, we will have am is simply equal to ak. This is because the next 2 to the power of n minus 1 term is just going to be repeating the previous 2 to the power of n minus 1 terms. With these observations, notice that 2025 can be written as 2 to the power of 10 minus 1 plus 1002. And then 1002 can be written as 2 to the power of 9 minus 1 plus 491. 491 can then written as 2 to the power of 8 minus 1 plus 236, and so on, until we obtain 46 is equal to 2 to the power of 5 minus 1 plus 15. Therefore, we have A2025 is equal to A1002, which is then equal to A491, and this is equal to A236, as well as A109, as well as A46, which is equal to A15. And we know that the 15 terms is equal to 4. In order to compute the sum of first 2025 terms, we are going to compute S2 to the power of n minus 1, which is the sum of the first 2 to the power of n minus 1 term in general first. Notice that in the first 2 to the power of n minus 1 terms, there are 1 n's, 2 n minus 1, 2 square many n minus 2, and so on, where there will be 2 to the power of k many n minus k in the sequence. Therefore, S2 to the power of n minus 1 is simply equal to n plus 2 times n minus 1 plus 2 squared times n minus 2, and so on, until 2 to the power of n minus 1 times 1. To simplify this sum, we can first multiply it by 2 to obtain this one, and subtract the first equations from the second equations, and this is what we get. Notice that the result of the difference is simply S2 to the power of n minus 1, and the first bracket on the right hand side gives us negative n, the second bracket gives us 2, the third bracket gives us 2 to the power of 2, the fourth gives us 2 to the power of 3, and so on, where the sum of the power of 2 at the back is simply equal to the sum of the first n term of geometric progressions with the first term 2, as well as common ratio 2, which is equal to 2 to the power of n plus 1 minus 2. Rearranging the result, we have S2 to the power of n minus 1 is equal to 2 to the power of n plus 1 minus n plus 2. Now with the s2 to the power of n minus 1 ready, we have Sm, where m is equal to 2 to the power of n minus 1 plus k, is simply equal to the sum of the first 2 to the power of n minus 1 term plus the remaining k terms at the back. And from the result we obtained earlier, each of the a2 to the power of n minus 1 plus k here is simply equal to ak. So it reduces to the sum of a1 until ak, which is simply sk. Therefore, we can now compute S2025 as in S2 to the power of 10 minus 1 plus S1002, and S1002 can be written as S2 to the power of 9 minus 1 plus S491, and so on. Until we get this one, where we can just plug in the formula for S2 to the power of n minus 1 to obtain this thing. By some simple computations, the result is equal to 4001, and this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.